Hey guys, it's me, Miss Mills, and welcome to Mrs. Mills' Math Time. The whole point of this video is to help you out with solving equations with variables on the both sides. So this video is going to go along with the notes. These notes are interactive, so you do have to watch this video and watch the examples in order to get the answers and explanations and step-by-step instructions into solving equations with variables on the both sides. So this is going to be a lengthy video. There's going to be there's just going to be a lot of content in this video, so you do need to pay very close attention, and just at the end, let me know if you have any questions. This is a skill that just takes a lot of practice, and once you practice it enough, you're going to know how to do it like the back of your hand. But you got to learn how to do it. You have to learn the steps, and you have to be very patient, and you'll be able to do it just fine. But this video is going to go right here, so you do need to watch this video in order to get all of the answers. It's going to be there. I don't even know why I say that anymore. All right, so steps to solving equations with variables on both sides. First step is you need to use the distributive property if necessary. So if you see a number and then the parentheses with numbers and variables inside it, you do need to solve that first. You need to use the distributive property first before you can do anything else. So that's an if necessary term. So if you see that, you have to do it, but you're not going to see that every single time. After you distribute, if necessary, you have to combine like terms, if necessary. So a couple of weeks ago, we simplified expressions where we located our like terms and we were able to combine them. Well, same thing here. Before we can solve our 1 or 2 step equation, if we can combine like terms, we do have to do that first before we do anything else. So distribute if necessary, and then combine like terms if necessary. But again, there's going to be cases where you don't have to do either of those things. And then after that, what you want to do is you want to collect all of your variables. So I want to change this actually, all of the variables. And I recommend you changing this as well. Oh no, it'll change, never mind. I don't have to do that. Collect all the variables on one side. So what I want you to do is when you have both sides, you're going to have variables on both sides. Like, it's the whole point of us solving them. One variable is going to be usually bigger than the other one. So you're going to choose a variable side and you're going to choose a constant side. So remember, your constants are your just regular old numbers. Your variable side is going to be your coefficients and your variables. And I'll show you exactly what I mean in just a second. So you're going to have two sides, of course. You're going to choose a variable side. And again, I recommend you choosing a side where the variable is the largest variable. Its number is bigger than the other side. Once you choose that, then you're going to collect your constants, so your regular old numbers on the other side. And once you have all that cleaned up, then you can solve your 1 or 2 step equation. But let's do some examples together. I'll show you step by step on what I mean. And again, here are the steps as well for multiple questions. But let's go ahead and solve this real quick. So the first question we have right here is 8x minus 7, and that is going to be equal to 4x plus 21. So in this case, you're not going to have to use a distributive property, and you don't have to combine like terms. But what we are going to practice is we're going to practice choosing a variable side and then choosing a constant side. All right, so let's do this. You can see my little doodles. I don't know why I did that. I don't know what I was doing when I made those doodles either. So, all right. So, guys, remember, first step when you're solving equations like this is go ahead and put the balance beam through the equal sign, okay? So what you're going to do is you're going to choose a variable side, a side where you want to move all your variables to, and then you want to choose a constant side where you're going to take all of your constants or your regular old numbers and move them to the other side. And again, I would choose the variable side where the variable is larger. So for example, on this side, our variable is 8x. On this side, it is 4x. And I don't know about y'all, but 8x is bigger than 4x. So I'm going to make this side my variable side. Now this is my variable side. I'm going to make this my constant side. My handwriting is trash. Anyway, so I'm going to choose my variable side. I chose this one over here because 8x is bigger than 4x, and then I chose my constant side. So since this is my variable side, I want to move all of my variables to that side. So I'm going to do that first. So I want to get rid of this 4x. I want to move it over here. So what I have to do is I have to do the opposite of a positive 4x because that's a positive 4x. The opposite of a positive 4x is, of course, a negative 4x. And if you subtract on one side, you have to do it on the other side as well. And what I like to do is I'm going to put it right under the other variable so I can go ahead and solve that. So I'm going to put a line under that. And I'll go ahead and solve this. 8x minus 4x is going to leave me with 4x left over. I'm going to bring down my negative 7, because remember we take the operation in front of it. I'm going to bring down my negative 7. These canceled out, they were equal to 0, and I'll bring down my 21. Okay. Now I'm going to move my constant, which is this negative 7, I'm going to move it to this side. Fair enough. I'm going to go ahead and do that, because this is my constant side, and I need to get rid of this constant anyway, or a two-step equation, whatever you want to think. So to get rid of this negative 7, because we take the operation in front of it, I have to do the opposite of a negative 7, which is a positive 7. So I'm going to add 7. And if I do it on one side of the equal sign, I have to do the same thing on the other side as well. So negative 7 plus 7, again, those are opposites. I'll go ahead and cancel those out. They're equal to 0. So I'm going to bring down my 4x. And then 21 plus 7 is going to give me 28. And then I can go ahead and solve for my variable. So I want to get x by itself. In this particular case, 4 is getting multiplied by x, so I have to do the opposite of multiplication. The opposite of multiplication is division. So I'm going to divide it by 4. And if I do it on one side, I have to do the same thing on the other side as well. So these cancel out. What I'm left over with is my x value. 28 divided by 4 is going to leave me with 7. And there you go. So what you can do if you want to check your work, this is what you can do, and you can do this every single time if you want to, just to make sure, is you can substitute your x value now into the original equation and make sure that they match up. So for example, I'll put the 7 into this side. So we have 8 times 7, and I like to put my variables, when I plug them in parentheses, so I can kind of organize my work better. And subtract that by 7, and then I'm going to put my variable onto this side as well. So then I have 4, 7, plus 21. All right. So first, 8 times 7 is 56. I subtract that by 7. And then 4 times 7 is going to give me 28. I'm going to add that by 21. And then you just, do the same thing. 56 minus 7, well, that is going to give me 49. And then 28 plus 21 is also going to give me 49. So you know what? X is equal to 7 because that is true. 49 is equal to 49. So that works. So if you ever want to check your work, that's what you can do. You can substitute your value into the original equation and make sure it works out on both sides. Make sure they're equal to each other. All right. So let's do our other example then. Well, I guess we need to go back to our notes and say that, hey, this answer was 7. X is equal to 7. All right, so here's the next one. All right, it's going to be very similar to the last one we just did. We don't have to distribute on this one, and we don't have to combine like terms, but what we do have to do is we need to practice moving our variables to one side and then moving our constants to the other side. So let's go ahead and do this. So I'm going to put my balance beam through the equal sign, and I'm looking at my variables first. I want to choose the variable side first. And in this case, negative 2 is bigger than negative 11. So I'm going to make this side my variable side. And if that's my variable side, well, this side is going to be my constant side. So now that I have chosen my sides, I want to move all of my variables to this side first. So what I'm going to do is I need to get rid of this variable. Well, this one is negative 11, so I got to do the opposite of negative 11 if I want to move it to this side. So I'm going to add 11. And if I do that on one side, I have to do it on the other side as well. And again, I like putting it directly under the other variable. So you can go ahead and do the math. So these canceled out. They were opposites. I'm going to bring down this plus 9. Negative 2 plus 11 is going to give me 9x. And I'll bring down this plus 45. Now that I've moved my variables, now I'm going to move my constants to the constant side. So I got to move this 45. So I got to get rid of it. So the opposite of a positive 45 is a negative 45. If I do that on one side, I have to do that on the other side as well. And then I can go ahead and solve again. 9 minus 45 is going to give me negative 36. These cancel out. And I'll bring down my 9x. And then I have my last step. I want to get x by itself. That's the whole goal. So I got to do the opposite. I got to get rid of this 9. And 9 is being multiplied by x. So I have to do the opposite of multiplication, which is division. If I do that on one side, I have to do it on the other side as well. Negative 36 divided by 9, well, that's going to leave me with negative 4. I'm moving it over because I ran out of room. And then these cancel out, leaving me with that being x. And again, if I wanted to check that, I could plug that into my original equation to make sure that it works out. In this case, that would happen. So I'm going to go ahead and move on to our next problem. So here we have x is equal to negative 4. Okay, next one. All right, so in this case, in this next problem we have here, this one right here, we will actually have to combine like terms first before we can do the other stuff. So we don't have to do the distributive property yet, but we will have to combine like terms before we can do this problem. So, and you need to figure out, well, which side do I need to combine like terms with? Well, on this side, I'm good. 14x and plus 1, those are not like terms, so I can't combine any of them. But if I look on this side, well, I have a negative 2 right here, and 15 are like terms. So I do need to combine those first. So I'm going to box them up. And remember, when you box them up, you take the operation in front of them as well. I need to combine these first. So negative 2 plus 15 is going to give me a positive 13 left over. And then I'm going to bring down this positive 8x. And then I'll bring the rest of this problem down. Bring down that 14x plus 1. And now I have my problem. All these are combined, whatever. Now I can choose a variable side and a constant side. So balance beam time. Made my balance beam. So now that I'm looking at this, 14x is bigger than 8x, so I'm going to make this side my variable side. So if that's my variable side, well, this side got to be my constant side. All right, let's do this. So I want to move my variables first. So if I'm looking at my 8x right here, I need to move that bad boy over here. So I need to get rid of it on this side. The opposite of a positive 8x is a negative 8x. If I do that on one side, I have to do that on the other side as well. All right, let's solve. 14x minus 8x is going to give me 6x. I'll bring down that positive 1. And then I'll bring down this 13. And then these will cancel out. And now I have a two-step equation, but you can think about it that way, or you can say, well, I need to get rid of my constants now and bring it to this side, so I need to do that too. So I need to get rid of this constant. So the opposite of a positive 1 is a negative 1, or the opposite of adding 1 is to subtract 1, same thing. And if I do that on one side, I need to do that on the other side as well. I'm smudging. All right. So I'm going to bring down my 6x because these are opposites, so they're going to cancel out. So I'm going to bring down this 6x. And then 13 minus 1, well, that's going to leave me with 12. And now I can solve for my variable. So in this case, I want to isolate the variable. And 6 is getting multiplied by x, so I need to do the opposite of multiplication, which is division. And if I do that on one side, I have to do it on the other side as well. What I'm left over with is these cancel out, leaving me with just my variable, which is x. And then 12 divided by 6 is going to leave me with 2. So there you go. X is going to be equal to 2. And again, if I wanted to check that, what I could do is I could plug that into my original equation, or I could solve it into this one too. After you combine like terms, you can turn it into, put it into this equation. It'll be the same answer. But 2 would be your answer if I plugged it into either of those equations. So I am good to go. So I'm going to go back to my notes. I'm going to say in this case, well, x was equal to 2. All right, so we got 3 problems left. This video is already moving pretty slowly, so I'll try to speed up a little bit, but probably not. You'll probably just have to be stuck with the long video. Alrighty, so now we're getting to the parts where you do have to use the distributive property first And then you can go ahead and choose the variable side and constant side and then solve for x. So in this case, you're not going to have to combine like terms, but what you will have to do is you will have to distribute first. And remember, you always have to distribute first. So let me go ahead and do that. So remember, guys, the distributive property says what I can do is I can take my outside number and I can multiply it by everything on the inside of the parentheses. That's what the distributive property says. So I can do that with these problems as well. So 3 times 2x is going to give me, well, 3 times 2 is 6. And then I can bring that variable down with it. Okay. So 3 times 2x is going to give me 6x. And then 3 times 1, well, that's just going to leave me with a positive 3. And then I have 5 times x. Now, guys, don't freak out when you see this. Remember, when you have a variable by itself, what that means is you have to automatically assume there is a 1 in front of that. Okay? So what we have here is 5 times 1. Well, 5 times 1 is 5. And then I can bring down that variable. And then we have 5 times negative 4, because remember, you got to take the variable in front of it. Well, 5 times negative 4, remember, a positive times a negative is going to give you a negative answer. And 5 times negative 4, well, that's going to give me negative 20. Guys, I want y'all to remember this. When you're solving this, this rule right here is going to be the matter of life or death with solving these equations. Remember, positive times a positive, well, of course, that's going to give you a positive answer. A negative times a positive is going to give you a negative answer. And that's the same when flipped as well. A positive times a negative will give you a negative answer. But remember, a negative times a negative will always give you a positive answer. So if you don't have this written down in your notes somewhere, I highly recommend that you have that written down somewhere, okay? Because this is super important to solving equations. All right? So now that I have done this and I have distributed, I'm looking at both my sides. I cannot combine any like terms here, so I'm ready to choose a variable side and a constant side. So I'm going to choose my variable side first. Well, when I choose my variable side, I choose the side where the variable's bigger. In this case, 6x is bigger than 5x, so I'm going to make this my variable side. Again, terrible handwriting. So if that's my variable side, I got to make this my constant side. And I'm bringing them down here because I, ran out of room. Anyway, so variable side, I want to move my variables to this side first. So I need to get rid of this 5x and move it over here. So to get rid of this positive 5x, I need to do the opposite of a positive 5x, which is a negative 5x. If I do that on one side, I have to do the same thing on the other side as well. And when I do that, remember, I'd like to put it right under the other variables so I can go ahead and just solve that. 6 minus 5 is going to leave me with 1x. I'll bring down this positive 3. These canceled out because they're opposites. And then I'll go ahead and bring down this negative 20. Remember, we take the operation in front of it. So I'll bring down that negative 20. Well, now that I moved my variables to one side, now I need to move my constants to the other side. So I need to move this 3. I need to get rid of it. So what I'm going to do is I'm going to do the opposite of a positive 3, which is a negative 3. Or the opposite of adding something by 3, which is subtracting something by 3. Again, same thing. So if I subtract 3 on one side, I'm going to do the same thing on the other side as well. Ew, smudging. So these canceled out. They're opposites. So I'll bring down my 1x. Negative 20 minus 3 is going to give me negative 23. So x is equal to negative 23. That's my answer. And again, if I wanted to check that, what I could do is I could substitute my x value into my original equation. And I could solve and make sure that they were correct on both sides. In this case, that would be the case. So what I'm going to do is I'm going to go in here and I'm going to say, hey, you know what? X is equal to negative 23. All right, we have a few more problems left. Now, this next problem is where you have to use all the steps. You have to distribute, then you have to combine like terms, and then you have to choose the variable side and constant side and then solve. So this question is going to put everything into one multi-step variables on both sides equation. So I do need you to listen very closely when I'm solving this problem and follow the steps to the T. So we have 6 plus 12, that's going to be multiplied by x plus 3, and that's going to be equal to 7x plus 30 plus 6x. Cool. Okay, let's do that. So I need to do some stuff. This is getting kind of rough. Okie dokie. All right, so according to my steps, I am supposed to distribute first before you do anything else. Well, I can distribute first because what I have here is I have a number next to parentheses, so I need to go ahead and get that done. So 12 times x, remember, don't freak out. That just means there's a 1 in front of that. So 12 times 1x, and why is this still blurry? It's going to give me 12x, so I'll do that right under it. That looks terrible. All right, and then we are doing 12 times 3. Well, 12 times 3 is going to give me 36. And now I'm going to bring everything else down. I'm going to bring down this 6 plus down. And then I'm going to bring down this other whole side, plus 30 plus 6x. All right, so now that I've distributed, now I need to see, well, can I combine like terms? So let's look at this side first. Well, yeah, I have 6 and a 36 here. So I need to go ahead and box those up. I'll need to combine those. And if I'm looking on this side, okay, I have like terms over here as well. I have a 7x, and then I have a plus 6x, so I need to combine those two. So there's multiple terms that I need to combine before I can solve this problem. So 6 plus 36, well, that is going to give me 42. And I'll bring down my 12x down here. Okay, because this is a positive 12x, so I'm going to put a positive in between those. So I'm going to bring that down. And then that's going to be equal to, well, 7x plus 6x. And give me 13x. And then I'll bring down that plus 30. Cool. All right. So that is as simplified as either side is going to get. So that means I can choose my variable side and I can choose my constant side and go ahead and solve both sides. So I'm going to choose my variable side first, and I'm going to choose it based off which variable is the biggest one. Well, 13 is bigger than 12, so this is going to be my variable side. And then this is going to be my constant side. So now that I've chosen sides, I need to move all of my variables to one side first. Well, I need to move this 12x to my variable side, so let's go ahead and do that. So to get 12x and move it over here, I got to get rid of it on this side first, so I got to do the opposite. The opposite of plus 12x is, well, I'm going to subtract it by 12x. If I do that on one side, I have to do the same thing on the other side as well. And again, I like putting it right under the other variable so I can go ahead and solve that. All right. So these canceled out. They're opposites. So I'm going to bring down this positive 42. I'm going to bring it down here just so I can move it closer to the balance beam. 13 minus 12. Well, that's just going to leave me with 1x. And then I'll bring down this plus 30. Okay. So now that I moved my variables to one side, now I need to move my constants to the other side. So I need to get rid of this 30. This is a positive 30. So the opposite of positive 30 is a negative 30. And if I do that on one side, I have to do the same thing on the other side as well. Okay, so 42 minus 30, well, that's going to leave me with 12. These canceled out their opposites, so I'll bring down this 1x. So simplified, 12 is equal to x. And there you go. Guys, don't make it harder than it has to be. Follow the steps to the T. Remember all of your rules. Go down, take your time, and you'll be perfectly fine. Okay? And let me know if you have any questions. So again, if you wanted to check this, what you could do is you could plug this in to either one of these, honestly, would give you to that answer. Really, any of these equations, once you simplify it, it's probably going to be the easiest ones. So once I chose my constant and variable side, when I had all my like terms combined, I would plug it into that part because that would probably be easiest. But if you plug 12 into both sides, they would get the same answer. Therefore, they are going to be correct. So what I'm going to do is I'm going to say is x is equal to 12, and we have one problem left, and that's it.